Good afternoon. As I said, this is an excellent way to start an availability talk. So, just to give an introduction, my name is Sanjay Kalra, and I work for Juniper Networks in the product management group. And what I'll be talking about today actually is just give a brief introduction on what is availability all about. It is the latest fad in the IP networks actually. Then how to measure availability, give you an example on when you're designing a network, how can you use basically the availability calculations to design a good network. Then I'm going to talk a little bit about, like, people are saying that routers are becoming more and more reliable. You've got redundancy in every power supply or fan system. Everything is reliable or redundant actually. So then why you need two routers? Can you just get away by having one router? So let's go through pros and cons of both of these things. Then I'm going to talk about a little bit about software dependability. So all these calculations can be done easily for hardware, but when you talk about software, as people mentioned in the morning, there is no software without bugs. And measuring software dependability or availability is a tough thing to do. And then I'm just going to have a summary. So to start with, what is availability? I'm not going to read this, you can read it in your spare time. But in reality, availability actually is uptime by uptime plus downtime. So basically what it's saying is that if I have a system, I designed it, and it should stay up for its design purpose. That's the basic part of availability. And if you're a carrier, it would have happened to you by now, or it will happen really soon, that some of your executives or marketing department will come and tell you that they need 5 nines, without even knowing what that means, but they want 5 nines. So if you take a look at what really 5 nines means, 5 nines means basically you can have a downtime of 5 minutes per year. That's the maximum downtime you can have in the year. And the second thing that I want to tell you after they say that they need 5 nines is look at the voice network. The voice network gives you 5 nines or even better than that. So what I did actually was I kind of looked at what is the Telcordia standards for PSTN networks in terms of availability. And if you take a look at it from the Telcordia standards, they talk about a number of calls. And they basically say that you can have one cutoff call in every 8,000 calls, or you can have 5 ineffective calls for every 10,000 calls. And what they say is that individual element of the voice network should have an availability of 4 nines, which is 99.99%. And if you take a look at the network, which is like starting from a network interface to local exchange, going to the long distance, these are actually the unavailability numbers. So if you want the availability numbers, you can just do 1 minus the number which is there on the slide. For long distance, the availability number is like say 99.98%. And for access network, it is 99.99 or 0.01 unavailability. So you can take a look at this, and if you calculate end-to-end availability according to the Telcordia standards, the availability should be around 99.94%. This is also not 5.9. This is what it should be. Things are much more better than what is stated here, but this is the goals from Telcordia on what a PSTN network should look like. When we talk about availability for voice networks, most of the case times it is binary. Either you can make a phone call or you cannot make a phone call. There is no middle ground, unless you're doing cellular phones in which there is no guarantees anyway. But for PSTN case, there is only one service, which is voice, and either you can make the phone call or you cannot make the phone call. When you talk about IP networks, the availability is really a function of the application you're using. So if you take a look at the example of these two different kind of outages, and look at the red graph. If you look at the red graph, this is actually an outage which has got a lot of short duration outages. And if that is the case, that is going to have a severe effect on your voice or IP service, which is you can see on the right side graph. But if you have another kind of outage where you have got very more duration of outages, but like the outage time is more, but the duration or the frequency is less, that is going to affect your web more than voice or IP. So it's not simple saying that availability and it is going to be same for different services. So in IP networks, availability is a function of the service you're offering. So if you talk about the service in the IP networks, there are different kind of services, and all of them have different requirements from the network. So if we take a look at this chart, if you talk about real-time interactive voice over IP, in that case you need high availability. When we talk about internet service, it also needs high availability, but if somebody is paying you $49.99 5, and compared to somebody who's paying good money for real time interactive traffic, the availability you need is lower than the real-time traffic. So it really depends on what services you are offering before you can decide what is the right number of availability or how much money you need to spend for availability. So as I said, the first thing everybody wants is 5 nines. But how do you measure availability of a network? Do you measure based on every device, or do you measure end-to-end from customer to customer? Do you measure it for applications? What are the different ways in which you can measure availability? One of the ways actually you can measure availability is that you can take all your network, how many ports you have, and just calculate based on the number of ports, how much time these ports should stay up actually, and just divide by total number of ports in the sample period. So if you had 1,000 ports and they should remain up for 24 hours, that means you've got 24,000 ports should be available for 1 day. And then based on that you can calculate if they were down for 500 ports were down for an hour, you can calculate how much was the downtime, and then you can figure out availability based on the port numbers. So this is very good if you're talking about basically companies like which are offering dial-up services. If you've got dial-up customers, every port is just one customer, and if you've got 1 million customers and 500,000 are down for some time, you can easily measure availability based on that. But if you take, like, if you're offering dedicated access service, then you're offering a DSL service for $49.95 and you're setting an OC3 line for a couple of $1,000, and if you just kind of measure availability based on the port numbers, it's going to be really bad. Because the customer who's paying you more, you need to probably give him more weightage when you're calculating the availability. So this is just an example showing you how you can use port method to measure availability. I'm not going to go into details, but you can take a look at that. So as I said, the port method actually is good if you have got all the customers have almost the same kind of bandwidth and they're paying you the same amount of money, which is usually for the dial-up case. But when you're talking about customers or the core of the network, the other way to measure availability is using bandwidth. And what you can do is you can just take whatever the bandwidth you have in the core and figure out how much the total bandwidth is and what is the uptime for all the bandwidth and divide it by the total it should be available for. So this actually method is pretty good for core routers, or if you've got customers which have got huge dedicated access kind of customers. Again, there's an example which you can look at it, how you can kind of use this method to measure availability in an IP network. The other method actually, which is used by the PSTN networks and is used by a couple of telco companies, is called defects per million. So when you talk about availability, it is usually like 99.99 in terms of nines, and it's based on time. So you take a time period and you calculate availability based on that. But the defects per million is a number. So what you're doing is you're just figuring out what your network is and kind of turning everything into units, or 1 million units, and figuring out how many defects you have in that million units. And you can always convert defects per million to availability, because defects per million actually is equal to unavailability into 1 million. So if you can figure out availability numbers in 99.99, you can just find unavailability by 1 minus that, and then multiply by that by 1 million, and we'll get defects per million. And this actually is used by the PSTN network today, and they define that as the number of block calls per million calls over a year period. So this is an example of how you can measure availability using defects per million. So in this example, you've got 10,000 active access ports, and you've got an access router with 100 access ports which fails for 30 minutes. So you can say the total port hours which should have been available is 240,000 hours. But since you had this outage, then your total port hours which are available is which are down were 50. So you can find DPM by just dividing 50 by the 240,000 into 1 million, and you'll get the number which is 208. And if you wanted to kind of equate that to the availability numbers, that is basically if you can just take this number, and as I said, defects per million is equal to unavailability into 1 million. So this will translate into, I think, 99.98% availability. So you can either go defects per million or you can go availability. So I'll just talk about 3 different methods of measuring availability. and I don't know if you've been following, the T1.org has been looking at different ways of measuring availability, but there is no one standard way of measuring availability for IP networks. So when you say you have got 5 nines in the network, you need to really define what do you mean by 5 nines, how you're measuring it, like which method are you using. Are you using the port method, or are you using the bandwidth method, or using some other method which is not even listed here. So this actually, how you measure availability is good if you already have a running network. If you have a running network, you've got information on the network in terms of how many ports are there, what is the bandwidth, what is up, what is not. But how can you kind of design a network which is available? And if you're starting from scratch. So one of the ways of kind of looking at availability is just doing the calculations based on the Telcordia standards. And if you have elements connected in the series, and you had availability numbers for each of the elements, and these numbers you can get from all your vendors, is that if you've got 3 elements connected in the series, the total availability of that network will be if you just multiply all these 3 availabilities together. And so in this case, all these series elements have availability of 6 nines, but the total availability for this network is 4 nines. Because in a series network, your availability will be always less, the total availability will be always less than availability of the individual element. And it is as good as the weakest link in the chain. What if you have things in parallel and you want to measure availability? So if you have things in parallel, there is a formula which tells you how to measure availability, which is basically you've got 2 elements, E1 and E2, and you just want to measure availability. It will be E1 plus E2 minus E1 into E2. This is actually not a perfect formula because actually you can do better analysis using Markov models and all that stuff. But because here the assumption here I'm making is that the switch time is 0 and both these elements are available. But in reality that's not the case. In reality there will be a switch time between when one thing fails for things to move over to the backup. But this is good enough if you want to just compare 2 different networks. So just going through an example, if this was my network and I got these availability numbers from my vendor and I wanted to find out what the availability will be for this network, you can take a look at it. Basically you have individual elements and you just multiply all the individual elements and you get the availability, which is in this case 2 nines. And you can always find availability in terms of the year by multiplying that by 525,600, which is the number of minutes in a year. So what is the use of kind of measuring this availability? How can I use that in network design? So what I'm going to do actually right now is I'm going to take an example of a hypothetical network which you're trying to design and go over how, if you had these numbers and you've done these calculations, how can you figure out kind of a good design? So take a look at this example. In this example, these are the availability numbers for the different elements. And there are 2 parallel paths from edge to edge, and the availability for both of them actually is like one is 99.63 and the other one is 99.43. So these 2 are parallel paths, and as I said, measuring availability of each path is basically you're just measuring availability of the serial networks. Just take availability of all these elements and just multiply them. Now if you want to measure availability for both these parallel paths combined, that is going to be 4 nines, and it's more than the individual paths availability, because if you have got 2 redundant paths. But if you measure availability from CPE to the server, the number is around 99.9, which is 3 nines. The reason for that, actually, if you look at it, is twofold. The first one actually is that from the CPE to the edge, there is a single link connecting from the CPE to edge. And on the other side, you're using a technology maybe like FDDI, which has got lower availability, and the number for that is 3 nines again. So if I wanted to kind of have this network and I did all these calculations, and I wanted to kind of redesign the network to make sure that I get 4 nines instead of 3 nines, what are the things I can do? I can look at it that on the left side I can do something by adding a redundant link. On the right side I can do something by changing the technology which I'm using on the right side. And you can get all these numbers from all the vendors, or there are like standards published actually for these numbers. So that's what I did. I added one more link I added basically two connections from the CPE to the edge. And on the other side, right side, I changed the technology from FDDI to some other technology, maybe Ethernet, which gives me better availability. And then I again calculate the availability from the system, from the CPE to the data center. And this number comes out to be 99.6. Earlier it was 99.63, so there is actually improvement of 0.05 from CPE to the server. And if you take a look at the second path, earlier the availability was 99.48, and since we added this redundant path, now availability is 99.43. So again, there's an improvement of 0.05 in this case also. Now what is the availability for end-to-end? Earlier, end-to-end availability was, now actually it is 4 nines, and before that it was 3 nines. So by adding this redundant path from the CPE to the edge and changing the technology from FDDI to Ethernet, you increase availability from 3 nines to 4 nines. So when you're designing your networks, you can, this is actually just for comparative purposes. These are not the ideal calculations. If you want to do ideal calculations, you can look at the Markov chains or models and all and do the analysis. But if you just wanted to compare two network designs, you can take these calculations and just compare the design and kind of see and back of envelope to see what your availability will look like. And all these availability numbers are hardware availability numbers, not the software. So all the vendors, the router vendors or different switch vendors, publish their availability numbers based on their bill of material. And this is what I use actually in this example. The other thing which I actually wanted to talk to you guys about is that typical network design has always used two routers. If you take a look at it, every core network of every ISP, there are two routers everywhere. And there are two reasons for that. One is that people need redundancy or reliability, so they buy two routers. The second thing actually why people have two routers is it's easier in capacity planning. Because if you had 110% of traffic show up at any time, if you had a redundant router, you can handle that burst. But if you just have one router, it will be difficult to do that. So it makes the job easier of doing capacity planning. Now, if you look at the technology, it's changing, and every router you look at has got redundant power supply, fans, routing engines, switching planes, and forwarding plane. So if that is the case, do you still need two routers or one is enough? Being a vendor, the answer should be two routers, but that's not the case. It really depends on your network, and that's why I'm going to go into what are the pros and cons of both approaches. So just for a theoretical thing, what I did, I thought it might be interesting. I just used one of the Juniper routers, but you can do this calculation with any vendor's router. I just took two networks. What I did is I took one router, one network, with a router which is completely redundant, which had redundant power supply, fans, forwarding planes, line cards, everything was redundant in this router. And I took another network which had two routers which were not at all redundant. They had one power supply, one fan, and one routing engine, one of everything. And I thought it would be interesting to look at what will be the availability for these two networks. And if you take a look at the first case where the router is completely redundant, the availability for that single router is 5 nines. And the second case, each router has availability of 4 nines. But if you take a look at the availability for the whole network in this case, for a single router case, the availability is same as the availability of the router, because that's what the availability is all about. But in case of the two router case, the availability is 8 nines, because you've got two of these systems which are 4 nines, and if you combine them in parallel, they come 8 nines. And for a single router, the availability is 5 nines. But these numbers can be really misleading because these numbers are just for hardware availability. The reality is completely different. Another thing which I thought might be interesting is to look at the cost differences between these two configurations. And again, I just took Juniper example, but you can use any example you want. And the difference between the cost between the two models was that the two router model was 110% of the one router model. So what are the advantages of one router? So if you kind of can get rid of the second router, what do you gain? First thing is of course money, and which is I think pretty important for everyone here. The second thing actually is that if you've got less number of routers, you have lower OPEX because you've got less routers to manage, the network management cost is less. The other thing actually is the routing. If you've got less number of routers, the routing tables are smaller, so you get faster convergence. The other thing actually is that in some of the network designs or some of the points in the network, you don't have a choice. If you're talking about especially the provider edge, most of the times customer might be dual home and connecting to two provider edge, but the problem actually here is as per your concern, if you lose your provider edge router goes down, the customer is going to the other provider and you're going to lose money. So as per your concern, you want to make sure that your provider edge router is really highly available. And in that case, if you're especially hiring, like offering services, things like NAT, stateful firewall, which maintains state per flow, it's very difficult to have two routers. There is always a race condition. You're synchronizing the state between the two routers, and by the time you synchronize, the reply might come back from the other side. So in some of those cases, having one router is really good. The other thing actually is that when you talk about the provider edge, in case of Sonnet, there is APS. And you can have two links connected, and if one fails, you go to the other one. In a lot of other cases, when you're talking about TDMs, you don't have any choice. You just connect to one router. There is no other alternative. Another problem actually with the provider edge is that you might have thousands and thousands of customers connected. Like take a DSL box. You might have 16,000 customers connected to that box. And if that box goes down, you've got 16,000 phone calls in your support center coming in. So that's kind of pretty dangerous. So in those cases, you want to have one router which is really highly available. So what are the disadvantages of having one router? First thing actually is that it is still single point of failure. So if anything happens in the network, that's still the single point. The other thing actually is that now, when you have the single router, you have to have your configuration and upgrade process pretty much tuned up. Because anytime you want to upgrade your software or change the configuration, if you mess up, you don't have this backup router to go to. You might have two routing engines and you can upgrade one while waiting for, and then move to that one and then upgrade the backup routing engine. But still, if you're changing any configuration and the configurations are synced up between the two routing engines, and if you mess up anything in the configuration and the router is host and both the routing engines go down, you're going to have problems. The other thing actually is that, as I said earlier, people use two routers for two purposes, redundancy and capacity planning. If you have two routers, if you just have one router, your capacity management has to be exact. If you design your network for 100% of the traffic, if 110% show up, there's no way to go around unless you kind of go and buy another one and upgrade your network. The other thing actually is that the majority of the cost of the router vendors or how the vendors charge money is not by selling chassis. They charge money by selling line cards or plates or FPCs and things like that. So there's not much price difference between one router configuration and two router configuration. As I showed you earlier, the difference was around 10%, because the majority of the cost is in the line cards. The other thing actually which is kind of pretty important nowadays is that what if there's a denial of service attack against that single router. If you have two of them, there are good chances that the other one will not go down. But if there are only one, that one can really go down. So what is the other issues with one router? The first thing actually is the physical maintenance is not possible. So if you had your router in one building and suddenly you have a lot of layoffs and you need to vacate that building and move it to another building, if you had one router, it's very difficult to do that. If you have two routers, you can move one router and then basically move all your traffic to that router and after some time move the other router to the other building. But if you have just one router, you need proper downtime to do any physical maintenance. The other thing actually is that if you take a look at the errors or why networks fail, router failure of course is a major component, but the bigger component is probably link failures. So even if you have one router, you still need link redundancy. You still need two separate links. You need two separate line cards with two separate paths. You don't get it by having one router that you can have one path. You still need two paths. Also, if you have one router, physical separation actually is difficult in the sense that if you had an earthquake or a power failure or a water leak in one of the buildings and that building went away, then if you have only one router, that can crash. But if you have two routers, you can locate them into different physical spaces, and if one fails, you still have one of them available. And the last thing, actually, why actually the disadvantage of one router is that networks has always been designed with two routers, and if you want to design something with one router and you're going to be the first one, then best of luck. But it actually, this is actually a disadvantage right now, but it really depends on the trend. So if people kind of can design networks with one router and make it work and things, and I think actually in some scenarios, having one router actually is the ideal thing actually, because in some cases you don't have any workarounds. So what I talked about was how to measure availability, talking about network design examples, but I didn't talk about anything about software. This is mostly related to the hardware failures. So when you talk about software, one thing actually with the software is that software reliability is not a function of manufacturing. So if you've got two computers coming out of an assembly line, one can fail as soon as it comes out of the assembly line, other can run for 50 years without any problems. But in case of software, two copies of software coming out of a manufacturing line will be same. The other thing actually is that software does not degrade over time. If you have a hardware, if you've got a hard disk, if you keep on writing and reading from it, it will degrade over time. But software, it does not degrade. It degrades, like if you're running PC for a router for a long time or a PC for a long time, there are applications coming up and things, memory errors and things like that happen. But in reality, software should not degrade over time. The other thing actually is that physical environmental changes have no effect on software. So if the temperature suddenly increased or you had floods coming in or things like that, software does not get affected by environmental changes. Another thing actually is all the software failures are a result of designer or user errors. It is not because of some manufacturing problems. The other thing is that software can only be repaired by redesign. It's not that the hardware failed, you take out the hardware component and just plug it back in. So there is no concept of mean time to repair for software. Most of the times, the software problems go away if you just reboot the stuff. But in reality, if there is a problem and you have to reboot, then you have to rewrite the code to fix that bug. And the other thing actually, the biggest thing with software is that software bugs can be really contagious. It's more like virus. It spreads really fast, especially with networking. If you have a bug somewhere, it can kind of crash your whole network. In majority of the cases, when there's a hardware problem, it's most of the cases localized. If something happened, it fails there. But if you have a problem in your BGP code or IGP code, it can probably mess up your whole network. The other thing, actually, the last bullet is just a nice way of saying that there is no software without bugs. Because especially for IP routing, everything you see, there will be bugs because the things are pretty complex and things are changing really fast. So in summary, I'd like to point out there is actually no standard way to measure availability. There are a lot of different approaches, but I have not seen one approach because I talk to a lot of different companies and I ask them how they measure availability, and I've not heard same answer from two different customers, and everybody uses different things. The other thing I should like to point out is that availability for IP networks really depends on the service you're offering. So if you're offering voice over IP, the availability requirements are completely different than you're offering email or data backup. Third thing, basically the difference between one router or two router, it really depends on your requirements. There's no one right answer. And the last, there are a lot of developments happening in the IP networks to improve availability. There's like graceful restart, non-stop forwarding, hitless RE failover, fast reroute, and a lot of different things happening in the IP networks to kind of make things more available. So, any questions?
I think your comments about the service being offered were, very well put. I think, with just general internet traffic, it's not point-to-point, it's not predictably point-to-point, so very hard to model that type of thing. So the phone, availability of the PSTN is you pick up the phone and there's dial tone, not you can dial any other number, right? So people might think of internet service availability as their ability to reach any other destination, but it's kind of intractable to measure that. which is that.
I agree with you, actually. It's kind of very difficult to do measurement for IP. In PSTN, there's only one service, which is voice, and usually it was point-to-point kind of a thing. So it's easy to measure availability for PSTN network. But for IP, it's a tough thing to do.
Yeah.
That's why there's no standard way of doing it till now.
Till now, you say?
Yeah.
I mean, I'd say, you know, that standard way of doing it is reasonable, but it sort of it defers the question of the just more general internet, you know, availability of an internet service, which is okay, I think, as long as the user community understands that, you know, that you can't sort of put a guarantee on their ability to reach any other part of the IP address space, you know, and with what quality. Yeah.
Because actually, I agree with you. Like, it's kind of, you cannot have any-to-any availability and kind of give quality to every destination. Like, there are how many millions of hosts out there in the internet, and if you want availability from every host to every host, it's a very difficult thing to do, actually.
Yeah. Thanks.
Okay. Thank you very much.
Thank you, Sanjay.